It's okay, you can hear me? I wasn't like that before. Okay, it looks like we are good to go, guys. So, I am going to be covering quality assurance in software development. So, what does that mean? Well, quality assurance in most areas normally means the same sort of a thing. Are we going to be able to maintain a certain standard in the work that we're delivering as output? So when you're working on a software project, either as a development team, a project manager, or a client, you're a client and you've contracted out a team or got freelancers in, whatever it is, if you're not from a development background, you're probably being a bit over your head about how you're actually going to maintain the quality in your product that these people are delivering for you. Now, this can be an issue, especially if you come from a non-technical background. But there are several things that you can try and get your team to be on top of and make sure that they're working on. So the main areas of quality assurance within software are code structure, code style, static code analysis, code reviews, manual testing, automated testing, and regression testing, as well as client acceptance. So what we can do then is start breaking these down bit by bit so you can understand what they're for, what benefit they provide, and then you can start getting the teams that are lacking these, provide them some information and get them start reporting back on how they maintain their QA to make sure that your product is being delivered in the best way possible. So code structure is normally a key indicator of if you've got a good developer or a bad developer working on a product. When the structure is terrible, doesn't follow any real patterns, it's all messy, things are all over the place, you can't actually follow it, it's a mess to work with. This causes problems for bugs in the future, trying to identify where bugs are coming from, what the cause of the problem is, and even just another developer coming on board to work on a product. If I jump onto a product that's been poorly written, all they're doing is wasting my time trying to understand how the shit is put together so I can work on it properly. That is no good for anyone. How do they know that a different developer is not going to look at it in their own team in a day, 2 days, a week, 3 weeks, a month time and be able to follow what the hell is going on? It's a poor way to do something and it really needs to be following a certain structure. Each language has their own structure and you need to follow the right structure for the right language. Otherwise, when you get someone from that other language, someone who's proficient in that language, reading structure from another language, it just adds more complexity and headache again. Now, all this mess of code has a term called, which we learned very early in spaghetti code. It's called that because when you look at a plate of spaghetti, you have no idea what the hell's going on. It's just all mixed, mashed together, and there's just a lump of pasta on the plate. That's what you get with code, a lump of code that doesn't make much sense and is all tied together. Now, tying into code structure, we have code style. So let me have a drink of water first. Now, each language has a certain style that you have to write code in, which is similar to the structure, but it's not how you structure your code overall. It's, are you using the namespaces correctly? Are you using capital letters in the right places? If you don't do this at a glance when looking at a specific language, you won't understand what is what in the code. So is it a function? Is it a variable? Is it private? Is it local? Is it global? Things like that. You can't use the style from, say, C# in JavaScript and vice versa. If you do that, all you're going to do is just cause more confusion and chaos for the developers who have to come into the project further down the line and work on something. So sticking to the right style for the right language is key and makes it easier for everyone to work in that language. You get better at something by doing something well and doing it over and over. The same applies to coding. So there is an automated tool which can help with this, and this is a set of tools called static code analysis. There's different tools for different languages and different platforms and development environments, but what they allow you to do is, prior to code compilation, run checks against all the code that is written and make sure that code structure and code style is being maintained with a standard for that language or a different set of standards if you want to follow and define your own, so that the code that is written follows them. If it doesn't, it raises warnings and errors and then throws complaints and stops the compilation from happening. You might not have heard this term compilation before. What that means is certain languages have to be compiled from the code that a developer writes into bytecode or assembly through a process called compilation, and then the computer can understand the output. It's in that step where we can throw an error and cause a problem for the developer to fix it and get it back on track before they release it and try and test anything. Now, another sort of level of code analysis, code review, another level is code reviews. What code reviews let us do is get an experienced developer or another developer in the team. They can be the same experience and even less as well, depending on if you want to train the team or maintain them. And they'll get a developer to run through all the code that has been written, look at style, structure, like naming conventions, because you might have a certain way of naming things which can't get caught the other ways, as well as logic. And I'll go through, they can look at the code, leave comments, flag things that are wrong, incorrect, and sometimes provide another way of doing something. So everyone in our team has benefited from these code reviews because each person can learn something from someone else who knows something that they didn't. So you might say, all right, this function can be written this way, and then they'll use that next one because now they've learned something. Or I didn't know I could do that, and you've learned something yourself by looking at someone else, the way someone else has done. If you get a lower experienced developer to look at an experienced developer's code, that is more of a learning opportunity for the less experienced person than it is the other way. But code reviews are a critical tool in getting consistent quality and maintaining that development level is getting done to the standard that you expected, and that all developers can understand it. They might even flag out that they need more comments in the code, and that's useful just down the track. So then another developer who comes on board in 1 month, 1 year, 1 week's time can actually understand what's happening in that logic. Sometimes developers forget to document things. So having that extra backup as someone who can say, all right, put some comments here to explain this, why did you think this, what's the process, becomes a very useful tool when you're trying to debug something down the track, weeks after it's been written and you've forgotten about it, and you need to try and understand why a bug has happened and how to fix it. Now, every bit of code that gets written should actually be tested by a developer. This is just manual testing. There shouldn't be any code that someone writes that they write it, commit it, and ship it. You always have to have some manual testing. You need to test that the code you're writing works. You might assume it's going to, but it's not always the case. Even something as trivial as updating a bit of text on a page somewhere can cause a crash. You might copy paste text from somewhere and paste it in, or you might add it, or you might type it yourself, and there could be a character that it doesn't like, and it's only a problem at runtime, it's rendering. Nothing will catch that until you actually run it. It's imperative that you test all the code you write, and you get you guys to test the code that they write as well. But manual testing also comes into your client acceptance. So you should be manually testing code, not the code, but the features that are developed when they're provided to you for acceptance. And we'll get to that later. Now, the next level from manual testing is automated testing. This can sometimes be a hard concept for people to grasp. How do you write code to test code? But that's effectively what it is. You're writing code to test code that you've written. You will normally write, all right, I'll define this variable, get this function, provided this variable, get the result, and then I expected the result to be this. And then when it runs that test, which is just a simple little play button in your development tool, and you're going to run tests, it will then give you a result saying test passed or test failed. If the test failed, it will say you expected blah and you got blah. And then you now know that this function has a problem. It'll tell you the line of code that happened on. You can step through it line by line and identify what went wrong and why. And then that gives you a great way to fix a problem before it gets sent out to users. What automated tests let you do is grow your code to scale. So you can write thousands of tests, get 80% of your code covered by these tests, which is called code coverage, and it's pretty good to keep that at a high number. 100% isn't always feasible. And then when you write code, you might inadvertently wreck something else in the system in another part of the code. These automated tests help you catch those because tests are being run on code that you haven't touched, that you haven't written, but it caused an issue somewhere else. So these regressions that happen get caught and then can now be fixed. Again, another great step in fixing problems before they send out to users and cause issues. If you want to see a good example of some code that an automated test would not have necessarily picked up because the test was written poorly or the logic was complicated, have a look at the blog post on our Aaron website called What is Quality Assurance for Software Development, or my LinkedIn article of the same name. And there's a code block with some explanation of this would have passed, but then making a code change, it still wouldn't have passed depending on the automation because the test wasn't written for that. And there's certain edge cases where it doesn't necessarily catch everything. So you sort of need to be on top of them and update the test as you update the code. But your team should be able to provide you with a testing report of all the tests that are run, and if they passed or failed, to at least give you some confidence that they're happening and that they're being written. Whether you understand how to write them or not, it doesn't matter, as long as you've got some confidence and visibility and coverage and results. And then the last sort of step is your client acceptance. You are depending on if you're a client or if it's your own team, there is generally someone who is the final gatekeeper to say whether something that has been delivered as a feature is accepted or not, and whether it should go live out to the production environment and be used. Now, we have a process where we define this client acceptance upfront prior to our engineering, during our engineering step, and then provide that to the client so they know exactly what's going to be delivered, how they're validating what's delivered. So this puts everyone on the same page. Everyone's clear on what the expectations of this feature are, how it should be delivered, and then once it's delivered, they can test the feature against those requirements. And we'll also provide testing reports and what test cases we run to make sure all that's sort of met. Without doing this, a client's expectations can be missed or unheard in the process, and something that's delivered doesn't meet them. And this can be a problem due to developers not following stuff properly, expectations were never upfront, and no one's on the same page. So bringing this upfront and making it transparent at the start gets everyone on the same page to deliver features that you need when you need them the right way. Now, if you are a startup or a founder and you're working with a team overseas and you're having a lot of issues, if there's continual bugs that keep happening, things are never delivered properly, something was fixed a month ago and it popped up again, you might have this problem where the quality assurance is not at the level that should be, and some of these aspects can be brought into your project. Now, whether you have some of these, all of these, or none of these, you really need to look at, if you have all of them, how can we improve them? How can we get more coverage if need be? If you have none of them, start getting something in place. Stop getting your developers from working on features. Start getting them to write some automated tests for the next few days or week and get some of this in place. You'll be surprised at how much time it can save in long term doing this up front and then adding stuff. You don't have to do the entire system either. You can only do the really complex parts if you need to begin, just to begin with something. So that way you have some confidence that when code is written, it doesn't affect previous parts of the product. And if you enforce this standard as you go through, you can then get your developers to write these tests as they write the code, and then over time you will get a larger code base being tested. Now, this can be something they can automate through continuous integration tools, where every time code is checked in, it automatically runs a test and you get a report. They can provide it to you at the end of the process. But if you think about 3 people on a testing team testing for 3 days every time a feature is released, that is 75 hours of work every time you have to do a release, where you might do that once or twice up front and get a chunk of it done, and then tests are written, but then you never have to repeat that same manual process over and over and over. It just helps you scale and speed up the entire process. Now, not having a technical background becomes a problem when you're looking at code reviews, code style, and code structure. Unfortunately, it's not something that you'll be able to pick up easily. It takes a long time to be proficient in some of these languages and understand how and why things are the way they are and how to write it well, and looking at things like that to understanding whether they're written well or not. But there are plenty of resources and development companies around who can offer code review services and provide this as an extra thing for you, so you can then get some more confidence in the team or the product and make sure that things are on the right track. We offer this as an advisory and a consulting service, but I'm sure any other development firm in Melbourne is capable of this, as long as they've got a few years of experience and have some solid developers on their team. Really, you just need to get some of these in place to start building up that quality, which helps prevent issues long term. A lot of bugs that can happen can be prevented early on in the pipeline if they get caught, but you need to have the right procedures and things in place to catch them. Now, if you want some more resources like this, have a look at our Arium blog, have a look at our YouTube channel, have a look at Andrew or myself's LinkedIn articles and posts. We've got a lot of content about trying to help people in startups, founders, or working on new products with no tech background, and what the things that you sort of need to know and be aware of how to develop a product well. We've had a lot of scenarios where we've had good teams working on stuff and everything works well, and then also scenarios where the teams are terrible and what's developed is garbage and something can't be worked with, you have to scrap it and start again. So before something gets too far away from you, try and get some of this in place, get a third party to come in and review it prior to getting too far into it, make sure things, get suggestions in place, make the right changes and recommendations, and try and get your product developed the right way from the start. We want to see your product get to market doing what it should do with the people, for the people it should be doing it for. Everyone wants to see your product succeed. No one wants to see it get rewritten and have 4 versions before you get something useful and wasting your money. So if you ever need to ask a question or reach out to us and ask an opinion or a thought, feel free to drop me a DM on LinkedIn, Facebook, Twitter, Instagram, wherever it may be. Leave comments on the posts. If you have heard stories from people going through a development and they're having issues with what they're working on, they're telling you about a product they're investing in and they're having a lot of problems with the team, send this out to them. Let them be aware of some of the stuff that they sort of need to be aware of. And we're here to help them. So let them know that we're available and we can help them. Thanks, guys.